Hello everybody, getting ready to start 3.6, Algebra 1, Model Direct Variation. It'll be part 1 of this lesson. 3.6, Model Direct Variation. So we're going to have 30 points here for a classwork skill sheet and 8 points here of note-taking. That's going to happen. Part 1, here is our standard here. And we're in Chapter 3, almost done with Chapter 3, 3.6, Modeling Direct Variation. Teachers, here is the bell work for this lesson. Slope and y-intercept, and then slope and y-intercept. Give your students about 4 minutes to complete this. Okay, welcome back. We're going to our solutions now for our bell work. And then y equals negative x, and m equals negative 1. Here's our negative 1 here. There is no y-intercept. Y equals negative x is the line that goes like this. And then identify slope and y-intercept the line with a given equation here. So negative 4x plus 8. So our m would be negative 4, and then our y-intercept would be 8. Okay, modeling direct variation. You wrote in graph linears. You'll write in graph direct variation equations. So two variables, x and y, show direct variation provided y equals ax and a cannot equal 0. Y equals ax. The non-zero number a is called the constant of variation, and y is said to vary directly with x. The equation y equals 5x is an example of direct variation, and the constant of variation is 5. The equation y equals x plus 5 is not an example of direct variation. Okay, students, here is your key vocabulary that goes in your notebook. Put this in your notebook, students. And here's your definitions here. Direct variation, y equals ax, is an equation where y varies directly with x. And then in this one, constant variation, in the equation y equals ax, a is the constant of variation. Here is your constant here of variation. Write these down, put these in your notebook, so when I check your notebooks on Friday, you'll have them in there. Okay, so example 1. Tell whether the equation represents direct variation. If so, identify the constant of variation, okay? 2x minus 3y equals 0. Tell whether the equation represents direct variation. Try to rewrite the equation y equals ax. So, okay. So we write the original equation, then we move over our negative 2x over here. Y equals that. See, what do we got here? Then we have y equals 2/3 x. We're going to simplify here when we're solve for y. This is what we get. Y equals ax represents direct variation. Yes, this is that form. Here's your a here, here's your x, here's your y. Constant of variation is 2/3. Okay, 2/3 x. Okay, example 1. Here's another one, number b. Negative x plus y equals 4. So we're going to see if we can put this in this form here. And what we have here is negative x plus y equals 4. Y equals x plus 4. Add x to each side. Is that direct variation for a form here? Y equals ax? It cannot be written in the form because it does not represent direct variation. Negative x plus y equals 4 is not in y equals ax form. Okay. Okay, tell whether the equation represents direct variation. If so, identify the constant of variation. For this guided practice here is our equation here. And when we solve for y, we have y equals x plus 1. This moves over here. It's positive. Because the equation cannot be rewritten in this form here, y equals ax, it does not represent direct variation. No direct variation here. So direct variation graphs, notice that a direct variation equation is a linear in slope-intercept form, y equals mx plus b, with m equal a and b equals 0. The graph of direct variation equation is a line with a slope of a and a y-intercept of 0. The line passes through the origin. Let's see here. So graph of direct variation equation, we're going to graph this one here. Y equals 2/3 x. Plot a point at the origin. The slope is equal to the constant of variation, or 2/3. Find and plot a second point. Here it is. Here we go up 2 over 3. So we're rise over run. So up 2 over 3. 3, 2 will be our next plot here for this line here. Then draw a line, which there it is. Okay, so example 2, graph direct variation equation. Graph direct variation equation. We have y equals negative 3x, so plot a point at the origin. The slope is equal to the constant of variation, or negative 3. Find and plot a second point. So here we go here. Here's a second point, 1, negative 3. So we have rise over run, or it's negative 3 over 1. So rise will be negative 3, and then our run would be 1. So it'll be right here at 1, negative 3. That'd be our second point, negative 3 slope. And that is the line. Okay, graph direct variation, y equals 2x. So we're going to graph that, students. Here's yours here. Ah, I gave that to you. If you're looking, it's already there. Okay, so into our graph here of this, y equals 2x. We know it goes through the origin, 0, 0. What's our next point? We have 2 over 1. Slope of 2 over 1. So we go up 2 and then over 1. Here's our next point. When x equals 1, y equals 2, so it's right here. Okay, so for part 2 and 3, email me here. Thank you very much.